patient, let's say several days ago, and they asked for permissions, and I have mentioned to them that for me there's no permission as soon as they enrolled as one of the students in the class, and got the if they have the permission from the how can I say, I don't know the words in English for phòng đào tạo. Yes, as soon as they can receive the permission from this department, and then yes, um, they they can attend the course. And without the permissions, they still can attend the course, but without taking the final test at the end of the semester. Yeah, that's the point. And yeah, we are talking about the test holiday. So test is coming, and yeah, for the moment, I believe that there's many of you who are very busy for the plan regarding the test, and we will start the course at 12, and we will end the class more or less 3, but I'm still here until 3:35. In the case that you have any questions, you can ask me until 3:35, but we can end the class more or less 3. As normal, we run the class for every minutes, and then afterward we have a short break for around 10 minutes. Yeah, because I have mentioned several times that I speak more frequent when I run the class online. So this is necessary to relax a little bit, to recover. Yeah, my voice, let's say. Yeah, that's some information. And yeah, 3 weeks. This week, the next one, and the week after the state holiday, we will run the class online. So both for the 2 courses. And before starting the second chapter, I would like to highlight the first one. Let me share my screen. Oh, come on, where is it? Here. So for the first chapter, we were talking about the fundamental properties of materials, and these were divided into 2 main components. So the first one, we really study the several mechanical properties of materials that can be used for aerospace industry. This can be the, for example, hardness. This can be the macro hardness measured by the Brennan hardness tester, or this can measure by the Vickers hardness for those which are harder than the, for example, non-ferrous alloys, which is need the higher scale in order to measure hardness of the material. You can also use the Vickers hardness for measuring the micro hardness. So Vickers hardness are quite great because it has the continuous scale, which can measure from the soft material until the very hard materials. Yes, but it takes a little bit longer time in order to measure comparing to the Rockwell hardness, for example, Rockwell C. For example, the Rockwell C's. We also deal with different kinds of properties. Can be the mechanical properties, thermal properties, like thermal expansion. Yeah, every material expands when we heat them up, and contract when we cool them down. So it's normal. And the other properties have already been mentioned during the class, and is somehow related to the cost of strength of material. For example, the strength, yes. For example, the stiffness, yes. And you have the relationship between the stress and strain, and we have the stress strain curve for every material. Let's say the elongation, percentage elongation, in order to show whether the material behaves ductile or in ductile regime or in brittle regime. So we know that if the percentage elongation is larger than 5%, and then we may consider the material as the ductile material. And in the remaining case where the percentage elongation is smaller than 5%, and you have the brittle materials. And for the ductile material, generally speaking, you have a damage tolerance, because if there is an impact force applied onto the component made of ductile material, and in that case, if the stress occur inside the material is larger than the yield strength, and you can have the plastic formations. And then the stress continues increase up to the ultimate tensile strength, and then afterward you may have the fracture. But for the brittle material, and if you have the if the external load applied onto the component is larger than the yield strength, and then you may observe the sudden damage, and there's no damage tolerance. So this is unexpected for the aerospace structures where you need the damage tolerance. Yes, and the second section and the second part of the chapter 1, we were talking about the material selection, and there are a lot of criteria that we need to consider. We have focused on the let's say the graph generated by the Professor Michael Asby. Yeah, I have talked to you, and here on this slide you can see that there are several criteria that you can consider when you select the material for aerospace for an aerospace application. One of the most important things that you should consider initially, because if it's too expensive, and then it's meaningless in order to consider in the next step. This can contain the purchase cost, processing cost. So is regarding the manufacturing phase, and therefore you may see that the relating costs can have, for example, the machining cost, the forming cost, shaping and forming more or less the same. The heat treatment cost, of course, is in order to give the material certain properties, especially during the manufacturing process, like for example the cutting, and the material should not be so hard, otherwise the cutting tool will be fastly worn, and then you need to, how can I say, replace with the new cutting tool, or you have to reshape the cutting edge of the tool before continuing the cutting process. In service maintenance costs, well, sure, you work with aerospace components, and you see that many aerospace engineers did not work with they do not work with the designing process, but instead they work with in-service maintenance. So it's quite an important work, yes. And yeah, of course, we should not forget the in-service maintenance cost. Yeah, when selecting the material for certain components, this may include the inspection cost and reparation cost. Yeah, for sure. Recycling and disposal costs. Yeah, of course, if you need. Availability, yes, because if this is plenty and cost may be reduced, but if it is too hard in order to find a suitable material for making a certain component, and then it's been rise significantly the price, yeah, of the materials, because of the unique material. Yeah, it's quite difficult in order to find. So let's say titanium is one of the expensive materials. Nickel, yeah, is also expensive, and the other. Of course, for example, for let's say wire, we copper alloy instead of gold. We know that gold has the highest electrical conductivity, but due to the high cost, we did not use for the general electrical component in in airplane. But for the other application in computer and computer field, yes, it's possible to use. Manufacturing, yeah, it should be easy for manufacturing. Otherwise, yeah, it will take a long time in order to fabricate the parts and as and then we have to apply the heat treatment, for example, in order to promote the ease of manufacturing for the materials, in order to reduce the cost of manufacturing process, for sure. Yeah, that's why we need to reduce the cost. We need to make the manufacturing process faster. Yes, or rapid manufacturing process. The density is mean the mass or the weight of the component, which is strongly contributed by the weight of material itself. Because even you optimize the shape of the structures, but then you use the heavy material, and then the part will be heavy as a result, of course. So for the same components, if you use steel, so it will be more or less 3 times heavier than you use the part which made of let's say aluminum alloy. And this is one of the criteria that you need to consider when selecting the suitable material. And you know that for aerospace structures, we tend to use the material which is light, for example, which are light, for example, aluminum alloy or titanium alloy or nickel-based super alloy instead of steel. But anyway, steel is the traditional materials, and for the heavy loaded structures. So in aerospace, yeah, is people still use steel. For example, the landing gear, yeah, can people can employ steel as the use materials. Yeah. Static mechanical properties like stiffness. We're talking about the elastic modulus, yeah, or the stiff, the slope of the stress strain curve within the elastic region, yeah, which means the stiffness. Or the strength, we are talking about the hinge strength or the ultimate tensile strength. But normally we refer to the hinge strength because we want the component work within the elastic regime rather than the plastic regime, because when the plastic deformation occur, and this is the permanent uh, deformation, so without the elastic recovery, no, plastic one. The fatigue durability. So a lot of components in airplane working cyclically. So work in cycle. So like the gear is rotate, let's say clockwise for a number of cycles, and then counterclockwise for other number of cycles, and then the material can be damaged in terms of the fatigue. And in such case, this need to have the fatigue resistant. Yes. Again, the initiation and growth crack to avoid, yeah, the fatigue damage. Damage tolerance. I have mentioned to you that damage tolerance is strongly regard the ductility properties of the materials. Yeah, to resist the crack growth. Yeah, and failure under cyclic load. So this is better to, how can I say, to create the part with high surface quality, so that we avoid the formation of the crack on the surface. Because if there is a crack or the micro crack on the surface during the cyclic working condition, and then the crack can open and propagate through the solid material, and when the crack grows, and this penetrate to the solid material, and after a small number of working cycles, and the component can be damaged, so fracture occur. It cannot work anymore, and therefore, yeah, we avoid any formation of notch, hole, yeah, any change in the structural shape. So you should maintain the continuous in continuity in cross sections. So without the formation of the area with rise the stress or the stress concentration area. So we should avoid this area. Should avoid. Yeah, but there's oh come on. And yes, I'm sorry for a minute because the student contacted me and asked for the for the information about the class at the room G113. But because the guy attend the class on the third day, and he does not know about how we plan to organize the course. Sorry, I just stop for I just mute for a minute. Okay, so let's continue with the slide. And yes, the damage resistant again the burst drive. Or yeah, this is the unexpected thing because the burst can goes in through the engine and can create an impact force on the out the outer skin, the skin of the aircraft. And yes, and this should be considered during the designing phase. But yeah, and therefore the material should have how can I say, should behave in the ductile manner, so that if there is an impact force created by for example, mm, for example, the impact force created by the birth, and then there's no problem with the airplane during the flight. Environmental durabilities, yes, these were important things, but we will talk about this for the sixth chapter, so the last chapter of the course. We'll be talking about the corrosion resistance, oxidation, probably a little bit, the corrosion risk resulting from the moisture or the humidity of the environment. Yes, yeah. And where? No, we are not talking about. We're not going to talk about the where. Unless the some information in the first chapter. Space environment. Yeah. Okay, because there's many things that we need to consider, but here just some fundamental issue you should consider when selecting the material. So we just mentioned we only mentioned about the corrosion resistance when we are taking into account the environmental durability regarding the materials. Thermal property, yeah, should be thermally stable at high temperature, especially for the turbine blade in the engine, because it have to work at very high temperatures, more than 2000 degrees C. So it need to fabricate it by the how can I say, nickel-based superalloys. But since nickel-based superalloys can work at around 800 degrees C, and you need some kind of coating. So, for example, ceramic coating called thermal barrier coating in order to increase thermal resistance of the material. And just you need to pay attention to the fact that at high temperature, the material receives the energy, and therefore the free give energy is high. The system is unstable, so it leads to the softening process. So the strength will be reduced. So therefore, this is one of the things that you need to consider when you select the materials, because at high temperature the strength is low comparing to the room temperatures, and therefore even the part work at high temperatures, the strength must be enough in order to withstand the load. That is important point. The cryogenic properties is something regarding to the properties of the material at very low temperatures. So to avoid how can I say, I have mentioned that the material can behave brittle, because every material there exists and a point called ductile to brittle transition temperatures. So at that point, the behavior of the material changes from the ductile behavior to the brittle behavior. And at low temperatures, the material behave in brittle manner, so it's quite dangerous, especially if the part withstand, let's say, the impact force. So it's easy to be fractured, and so on, and so on. And electrical and magnetic properties, I would not like to focus on these things, because you should work with the cost electricity, for example. Yeah. But generally speaking, yeah, it needs to have the high electrical conductivity for lightning strikes. Yeah. So lightning on the sky. Yeah. We also we will also deal with the radar transparency. Yeah. Where just some information when we talk about the polymeric material or composite material, and because there are certain material that can absorb, help to absorb the radar wave without reflecting the radar, and then the radar cannot receive the information from the object that need to be detected, and we call the radar transparency. So there's no possibility to detect the part by the radar wave. This is mostly used for the military sector. Yes, like the some kind of fighter, yeah, fighter airplane. So it needs this kind of properties, but not for the commercial airplane. Sorry for a minute. Yeah. So just a minute. Sorry for the inconvenience. Students asking me during I deliver the lectures, but not before that. This is where is it? So on the 14th. Okay, sorry for that. Um, so this is the main information regarding the chapter one. So do you have any questions? Uh, do you have any questions regarding the first chapters? So as I already mentioned to you that there are mainly two parts. So the first one is regarding the fundamental properties of materials, but they are not all the properties of the material. We just selected some and discuss some properties of materials. For the other, you could read from textbook, yeah. And the second part of the chapter one is material selections. So I have summarized for on the last slide and have already remind you, yeah, a few minutes ago. Okay, and now we can continue with the second chapter. So um, what is it? Second chapter, yeah. And for the second chapter, we study ferrous alloy. Ferrous alloy is many types of alloys with having the main elements are, let's say, steel. I'm sorry, iron and carbon. Iron and carbon. And the combination of iron and carbon, we have different kind of steels. It actually depends on the compositions. So let's say for 0.2% of carbon and the remaining amount is iron, and then you have one type of steel. And by changing the composition or the amount of carbon inside the steel, and then you have different kind of steels. But this is the carbon steel. And once you add more type of elements to the iron and carbon system, and you have alloy steel. Alloy steel. And depending on the type and the amount of alloying elements, you would have also different kind of alloy steels. So and in this chapter I would like to mention to you several properties, characteristic of steel alloy, the binary phase diagram of steel, together with the method in order to heat treat the steel. So this means that you apply heat treatment in order to modify properties of steel. So like for example, the annealing is some kind of applying heat in order to, how can I say, bring the steel back to the more stable condition. Or you can use quenching, or you may be familiar with the name in Vietnamese called uh, tôi tôi thép, and the other type of heat treatment called, let's say, tempering. If you would like to modify the, how can I say, the surface properties of the steel part, and then you can apply carburizing or nitriding in order to increase the hardness of the steel and so on. So basically, we are going to study, yeah, characteristic of steel, properties of steel, the binary phase diagram of steel, the carbon steel, the methods for heat treat steel, and the designation. Designation is something like how you symbolize the name of the steel. Yeah. So that when you see the name of the steel, you can, how can I say, figure out the composition of the steel. The alloying elements can be used for this kind of steel, and the, how can I say, and the heat treatment applied in order to improve or to modify mechanical properties of that steel. So this is the thing that you need to deal with the second chapter. But the thing is that uh, I have read the frame structure of the course. So it's something like the instruction to different kinds of material without the how can I say, go in depth into the core knowledge of the course material science and engineering. And if the thing like that, if the thing is like that, and then it's quite difficult for you, to understand what have been mentioned during the course. And therefore I would like to introduce some additional information. Yeah, although this information is not listed in the on the course description or on the frame structure of the course, but is quite important and is necessary for you from a point of view in order to understand the following part that will be introduced to you next day or in the next month. That is quite important. And this morning I have download how can I say, lectures from the from Marine University in Vietnam. So let me call Đại học Hàng hải. Yeah, Viện Cơ khí. Yes. And since I can download this document, and I'm sure that you can also download this document as an additional reference for you in order to study the course. And this is in Vietnamese, so it's quite easy for you to read. Yeah, for sure. Yeah. And I will introduce to you briefly the beginning part of the second chapter, and then I will give you some information, how can I say, the fundamental knowledge about the course, which lay the foundation for you in order to understand the upcoming terms. Yeah, otherwise it will be really difficult to understand. Okay, in Vietnamese. Tôi có trao đổi với các bạn về cái nội dung của chương trình ấy. Thì cái chương trình của chúng ta, như tôi đọc cái chương trình khung và tôi soạn bài giảng cho các bạn ấy, thì cái chương trình này thiên về giới thiệu các loại vật liệu. Tuy nhiên là khi mà giới thiệu các loại vật liệu thì chúng ta phải hiểu được là cái bản chất là tại sao vật liệu đó lại có cơ tính như vậy, và làm cách nào để chúng ta nâng cao cơ tính cái loại vật liệu đó để cho nó phù hợp với cái điều kiện làm việc trong cái lĩnh vực hàng không. Tất nhiên là chúng ta phải xét từng cái chi tiết cụ thể thì nó sẽ ra được điều kiện cụ thể và vật liệu cụ thể. Chứ chúng ta không thể giới thiệu chung chung là đấy, ví dụ như là cái landing gear chúng ta làm bằng steel, nếu chúng ta không thích steel chúng ta dùng titanium, không thích titanium chúng ta có thể dùng loại vật liệu khác chẳng hạn. Thì cái đấy nó không có cơ sở khoa học của cái vấn đề lựa chọn, cũng như là cái tính toán ở trong cái lĩnh vực thiết kế các cái sản phẩm, đặc biệt là trong lĩnh vực hàng không. Bởi vì khi mà chúng ta tính toán kết cấu một chi tiết thì chúng ta quan tâm đến vấn đề vật liệu, chúng ta cũng phải quan tâm đến vấn đề kết cấu của nó, chúng ta cũng phải quan tâm đến quá trình manufacturing process, gọi là quá trình gia công để tạo nên cái vật liệu đó và tạo nên cái hình thái chi tiết đó. Thì để nắm rõ được thì chúng ta phải hiểu được về mặt bản chất. Thế thì cái chương trình của chúng ta thì chưa tập trung vào cái bản chất này. Thế cho nên là để giúp các bạn hiểu rõ hơn một chút về cái mặt bản chất của cái nhánh vật liệu, thì tôi sáng nay có tìm hiểu về một cái bài giảng của bên Viện Cơ khí của Đại học Hàng hải. Tôi đào được, cho nên là các bạn cũng sẽ đào được. Các bạn chỉ cần search Google thôi, Viện Cơ khí Đại học Hàng hải bài giảng vật liệu và kỹ thuật thì sẽ ra và các bạn đào được ngay, không có vấn đề gì cả. Tất nhiên là cái bài giảng đấy tôi cũng xem sơ qua thì cũng có một cái số những cái tiểu tiết nhỏ nó cũng chưa chính xác lắm, một ít nhỏ thôi, không thành vấn đề. Thì nó sẽ trang bị cho các bạn những cái kiến thức khá là nền tảng để các bạn hiểu rõ là, bởi vì trong cái chương này tôi lấy ví dụ cho các bạn là nó động đến cái giảng đồ trạng thái hai pha, có nghĩa là binary phase diagram, và trên cái giảng đồ đó nó sẽ cho biết là đối với cái thành phần của thép, ví dụ như là có 0,3% carbon chẳng hạn, thì chúng ta biết ngay cái nhiệt độ nấu luyện của nó là bao nhiêu. Chúng ta có thể nhìn ở cái bản đồ trạng thái chúng ta biết được, và chúng ta cũng có thể biết được rằng là cái tổ chức nó đi liền với cái thép mà có cái composition như thế nó là gì, và với cái tổ chức như thế thì chúng ta phải tiến hành nhiệt luyện ra sao. Thì tất cả những cái này thì nếu mà chỉ giới thiệu qua thì các bạn rất là khó để nắm được, chúng ta lại rồi lại học thuộc lòng một cách máy móc cả để làm gì cả. Thì tôi muốn để các bạn hiểu rõ hơn. Thì chúng ta trước hết là đi đầu tiên vào cái vấn đề cấu trúc của mạng tinh thể, bởi vì cái vật liệu của chúng ta nó được tạo thành từ những nguyên tử, đúng không ạ? Các nguyên tử nó được sắp xếp ở những cái vị trí cố định trong mạng tinh thể. Thì người ta quan tâm đến cấu trúc mạng tinh thể, bởi vì cái mạng tinh thể của chúng ta mà sắp xếp nó càng tuần hoàn liên tục, nó không có khuyết tật, thì cái cơ tính, cái độ bền của vật liệu, và đặc biệt là vật liệu kim loại, nó càng tốt bấy nhiêu. Mọi cái khuyết tật nó nảy sinh trong quá trình tổng hợp vật liệu nó đều có xu thế là làm giảm cơ tính của vật liệu xuống, cho nên người ta sẽ phải tìm ra cái biện pháp. Thực ra là có hai biện pháp, có hai cái hướng chính. Một là giảm cái số lượng những cái khuyết tật, những cái sai lệch xuống đến tối thiểu, thì nó cũng góp phần làm cho cái vật liệu của các bạn nó tốt lên. Và cái xu thế thứ hai thì nó hơi ngược đời một tí, có nghĩa là khuếch đại các cái khuyết tật nó lên, có nghĩa là làm cho cái mật độ của các cái khuyết tật nó lên đến tối đa, thì nó cũng thì các cái khuyết tật đó nó sẽ hạn chế cái sự ảnh hưởng lẫn nhau. Thì do nó hạn chế được những cái ảnh hưởng có hại lẫn nhau thì nó sẽ làm tăng bền cho cái cấu trúc của các bạn. Hai cái hướng đấy tôi có thể lấy một cái ví dụ, nó là vật liệu đơn tinh thể, mà chúng ta có thể dùng cái hướng đó để chế tạo ra các cái turbine blade, có nghĩa là các cái cánh turbine đúc bằng cái vật liệu đơn tinh thể. Thì vì nó là đơn tinh thể cho nên nó giảm được cái lượng khuyết tật xuống. Cái thứ hai là cái phương pháp thứ hai là phương pháp rèn dập. Rèn dập ở đây là các bạn dùng ngoại lực, các bạn tác dụng vào để tạo hình chi tiết. Ở đây là các bạn tiến hành đập bằng búa chẳng hạn. Đó. Thì nó sẽ làm tăng các cái sai lệch của mạng tinh thể trong cái vật liệu mà các bạn tiến hành rèn dập. Các bạn càng tiến hành rèn dập bao nhiêu thì cái độ bền nó càng tăng lên bấy nhiêu, vì các cái sai lệch nó dồn sát nhau lại, làm cho mật độ sai lệch nó tăng lên đến tối đa, nhờ đó nó làm tăng bền của kim loại. Thì đấy là hai cái ví dụ để cho chúng ta hình dung được là có hai cái hướng như thế. Tất nhiên là tôi sẽ đi có thể là cụ thể hơn một chút. Còn cái nội dung bên lề tôi sẽ hướng dẫn các bạn có lẽ là trong buổi ngày hôm nay thôi, và cùng lắm thì sang một phần của buổi tuần tới cái môn vật liệu. Sau đó thì chúng ta sẽ chỉ tập trung vào cái frame structure của cái course program thôi, và chúng ta không đi ngoài. Thì tôi phải giải thích kỹ cho các bạn bằng tiếng Việt, bởi vì nếu không các bạn lại hỏi là tại sao cái khung chương trình của chúng ta là không có những cái nội dung đó mà thầy vẫn cứ hướng dẫn cho chúng em học. Thì cái này tôi phải giải thích rất là rõ lại như thế. Cái đấy mặc dù nó không có trong chương trình, nhưng mà nếu như các bạn không tìm hiểu sơ bộ về nó thì chúng ta giống như kiểu là chúng ta mất cái nền tảng để chúng ta đi tiếp lên. Nó giống kiểu chúng ta cái cây nó mọc từ thân chứ nó không phải mọc từ rễ nữa rồi, thì cái đấy có lẽ là không nên. So let me continue with the slide. So, I'm not sure either. I'm sharing the slide at the moment. So let me do it again to be sure that I'm showing the slide to you. Yeah. Okay. So here you have how can I say, a quick view about the steel. The steel is actually a kind of alloy which is made of iron and carbon, and the main composition is iron. And by adding a small amount of carbon, you have a different kind of steel. But please remember that the amount of carbon should be limited, because the higher amount of carbon introduced into the steel, the more brittle the material is. And therefore, in general, we will use the steel with the amount of carbon smaller than 1%. So it means that more than 99% of steel is iron or made of iron. The carbon steel. But of course, in order to increase properties of the carbon steel, people can add more elements we call alloying elements in order to increase mechanical and other properties of steel. And in this case, we have alloying steel or alloy steel, but with small concentration. But of course, you still have some cases of steel having more than 10% of alloying elements, for example, the stainless steel, with the amount of chromium larger than 10%. So, like the alpha stainless steel, for example, that you still have a quite high amount of alloying elements. But yeah, I will talk to you about this steel later. The mechanical property of steel. So basically, it's very sensitive to the carbon concentrations, and increasing the amount of carbon, increase the brittleness of the material, and that's why people usually use the steel having the amount of carbon smaller than 1%. Here is the 1 weight%. Yes, so the percentage measuring by weight. Yeah, 1 weight%. And how to classify the steel. So there's different types of steel. So according to this figure, you see that the material alloys can be divided into two groups: ferrous alloys, so anything regarding the iron and carbon system, and and you may have also alloying elements. So these material belong to the group of ferrous alloys. And other type of metals can belong to the group of non-ferrous alloy. So non-ferrous alloy can be called hợp kim màu, and where you have the alloys made of aluminum, copper, titanium. Yeah, you can buy super alloys and other types of metal-based system. And for the ferrous alloy, you have two sub categories: cold steels and cast irons. So steel is mean theft, and cast iron is mean gang. Yes. And for the steel, depending on the amount of alloying elements, it can be distinguished into two other smaller categories called low alloy steel and high alloy steel. Low alloy steel is mean that the steel composed of iron, carbon, and low amount of alloying elements. Yes. And high alloy, of course, you should have the higher amount of alloying elements. And I have mentioned to you that for the stainless steel, yeah, you may add with more than 10% of chromium on nickel, and you have this kind of steel. So stainless steel belong to the group of high alloy steels. For the low alloy steel, yeah, this can be divided into three different type of steels, depending on the amount of carbon inside the steel. So low carbon steel, medium carbon steel, and high carbon steel. Yeah. And in each subcategory called low carbon steel, medium carbon steel, and high carbon steel, you have the other two let's say classes called plain or high strength. For the low carbon steel, plain and heat treatable. Heat treatable is mean that you can apply thermal treatment in order to modify properties of the steel. And non-heat treatable is mean that okay, with the application of the heat, there's no possible in order to modify properties of the steel. So in that case, you may increase properties of steel by using work hardening. So for example, forging process using the hammer, shaping the form of the part, and during this process you increase the strength of the material. Yeah, and high carbon steel and high alloy steel uh, can also be the groove for the tool steel, yeah, tool steel, or the cutting tool steel. But it's just the classification of steel, not very detailed, but you have some idea about different categories of steel that you could have. Uh, mhm. And generally speaking, low carbon steel or carbon steel can be used for how can I say uh, build up a building. So it's used for a cyber engineering field, but not for the mechanical engineering field. And for high alloy steel, you can use with limited application in aerospace industry. Yeah. So, for example, the landing gear. But I would say that since the density of steel is quite high, so almost 3 times the density of aluminum alloy, and therefore, yeah, we use the steel with caution because it's increased significantly the weight of the airplane, and therefore it's reduce the efficiency of using fuel. Yeah, for sure, because we tend to make a lightweight structures. But if we employ steel at the material, and then we significantly increase the weight of the airplane, and this is an unexpected thing because we want to reduce the weight. Steel are widely used because yeah, you know that on the earth there's abundant quantities of iron and carbon. Yeah, and therefore is the steels are widely used. Yeah, sure, for constructing the building, for example. Yes, inside the concrete, so usually you have the okay, and I say the frame which made of steel because the concrete withstand very good compressive load, but the steel on the other hand can withstand the tensile load, and therefore with the concrete is necessary to use the steel inside because for the ceiling, for making the ceiling, so usually you use the concrete, but in the middle layer of the concrete which made of ceiling, normally people tend to put the steel frame more or less at the bottom of the concrete, for example, concrete beam, because when the concrete is under the influence of the load, it tends to be bent like this, and the lower layer will be under the influence of the tensile load, and the upper will be the compressive load. So since the steel is how can I say belong to the lower layer, so it can help the concrete in withstanding the uh, the, the the tensile load. And above there's no steam, just the concrete, and then how can I say the ceiling can withstand very good, or the beam can withstand very good the compressive load. This is due to the high compressive loading ability, withstanding load ability of the concrete. So, but yeah, just some few things. Economic extraction, because the extracting process has been developed for 100 years for steel, and therefore yes, it's developed for quite a long time, and then the price is now significantly reduced. We have economic attraction, refining, alloying with the different kinds of alloying element to fabricate the alloy steel, and the fabrication process as well. And since we have many methods, we have many type of alloy steel. And as a result, you have a wide range of mechanical and physical properties for steel. So different steel, you have different mechanical and physical properties. And just by changing the composition of the steel, changing the number of elements, the amount of element as well. So you have different kind of steels. In aircraft, people just use steel for making 5 to 8% of how can I say? Just 5 or 8% of components are made of steel, and it's used mostly for the. It can be used for making the airframe. Why? Because it's heavy. It's heavy. And in order to save weight of the airframe, it's necessary to limit the utility of steel for making the aircraft structures. So just for making the safety critical structure components, which require relatively high hinge strength, which range from 1.5 up to 2 gigapascal. So in such a case, you will use steel for fabricating the aerospace component, let's say. In general, steel had quite high elastic modulus, high fatigue resistance, high fracture toughness in normal condition, let's say. This means that it can keep the structure integrity, yeah, without the formation of fracture during the working life of the part, which made of steel, let's say. Good performance, which means that it has a very good strength at, what can I say, within the temperature range from 300 up to 450 degrees C. And be careful if the temperature is reduced and if it transits to the, how can I say, brittle regime. And in that case, you must be careful because if the steam behave in brittle manner when the temperature is reduced and the damage tolerance is reduced as well. But just some highlight about that. And in short, I would like to let you know that the steel is used limitedly in the aircraft, and is mostly used for making the heavily loaded aircraft structures. Yeah. Yes. Now it's 5 to 1. So let's say that we can have 10 minutes break, and then we can resume the class at 5 past 1.